Good evening, class. We are meeting once again. We are going to continue our lecture. And today we are going to look at how to plot a graph and also how to program using Octave. Yesterday, the previous lecture, we looked at a couple of things. That is the overview of Octave. We also looked at how to deal with variables and principally how to create matrices and manipulate it. And we did a lot with the matrix manipulation. And I believe by now you are practicing and you are even discovering wonderful things out of what we did yesterday, we did in the previous lecture. So today we are going to move straight into how to plot. Okay, so plotting graphs. Let's start. Now, one of the aspects of Octave and Matlab is using it to plot graphs. And it is very powerful when it comes to plotting of graphs. Today, we will not be able to go through everything with regards to plotting graphs. However, I will expose you to the basis of it so that you can learn further to know all that it is about the plotting of graphs. So we are going to look at how to plot 2D graphs. You can plot 2D and 3D, but we are going to look at how to plot 2D graphs, that is two-dimensional graphs. Now from the slide, this is the command or the syntax for plotting a very simple two-dimensional graph. We have the command name or keyword as plot into bracket. And remember, the commands are functions, inbuilt functions. And so they need arguments to be able to return whatever they need to return. So you have plot x, comma, cos x, then we close it. Now this cos x, it doesn't mean it should always be cos x. Actually, it should have been x and then f of x, where f of x stands for any function at all, any function at all. So here is a particular case. X is the x-axis, and then the function f of x, when here we are using cos x as the f of x, refers to the y-axis. You remember in mathematics, f of x is the same as y. So when I say f of x, it also implies y. Now this x here is a vector. You know, it has a range of values. And then if the range of values are put into the function f of x, you are going to get the various corresponding points for the y. So this is the simple way of form of how to plot a graph with Octave or Matlab. And I'm going to go through the slides afterwards. I'll do some demonstrations. So just be patient. Octave uses the GNU plots to handle graphics. Let's look at some other features of the plots. We have figure. Figure is also a command. Now, when you make it figure 1, it means it should create a graph in a window with number 1. You can also say figure 2. Then it will number that graph window as figure 2 in that order. So n is any integer at all. And then if you just make it figure, it will create a new figure window with identifier incremental by 1. So it means if I create a graph and I have figure there, I create the next one. By default, the first one will be figure 1, the second one will be figure 2 in that order. So that is how we use the figure. Let's also look extensively at the plot command. Now you can also plot multiple graphs on one particular figure or one particular graph area. So this is an example. We can say plot x with its corresponding y1. So x1, y1 is one set of graph. x2, y2 is another set. Please, the x1 is not just a value, a single value. It's a vector. And this is also a vector. So you are plotting, let's say, 1, 2, 3, 4, 5, 6, 8, 9, 10 against if you are dealing with the square of the values. So 1, 2, 4 in that order. Let's say, yeah, 1, 4, then we carry on 9, 16 in that order. All right. So these are vectors and not single values. A typical case is what we have down here. It is plots. Then the first graph is x cos x. You can decide to use the same x for the other functions if they are using the same values, the same independent variable, then they can all share. But then if they have their own values, you can also specify as we have given in the general one. So this is x and then cos x, meaning we are putting the vector values of this x into this cos to generate the y component. The same x we are putting in the sine to generate, and the same x we are, which is here, we are squaring them. And remember, here you use x dot caret 2. Now, we use dot, if you remember in our previous lesson, the dot is used for element-wise operation. So it means each element in x should be squared. If you don't do that, you have an error. So this is how we indicate it, so that every element in x will be squared. Take note of this. Every graph, or especially when you are dealing with multiple graphs, definitely you need a legend or a key. And the legend or the key will differentiate or will tell us that, okay, this graph is for this function and this is for the other function and this in that order. So this is how we add a legend. You use the keyword legend, then these are string. Anytime you see something in quotes, it means a string. We want to display this as it is here. So the legend, the first legend is cos x. The second, because this one goes with this also goes with this, and this one goes with that. Because this one is just the text or a string we are displaying, we don't need to bring the dot here. The dot here is actually an operation, but here we are not doing operation, we are displaying. Okay. Alternative way of drawing multiple graphs on a particular graph area is to use the hold. Hold simply means when you plot the first one, keep it on the graph, and then plot the next one also on the graph and keep it, and then plot the third one and the fourth one and the nth one. So you can either do it this way or use the hold and do them individually. I hope it's clear. And these are other commands or properties concerning the graph. We have the clear figure. So you may have a figure you want to clear it to plot another graph. The hold, we have just talked about that. We also have grid on. Grid on will just add grid lines. Grade off will remove grade lines. You can add a title to your graph, which is very important. Every graph must have a title. It must have the x-axis label and then the y-axis label. So you can do that by using these keywords. So you type title into brackets, then in single quotes. These things are string. If you are displaying a string, then you bring, if you are displaying something that is a variable within this, then you don't need to bring the quotes. Right. So the normally for titles and other things, it's the string that we display. Then we have subplots. Now subplots is used to plot more than one graph. Okay, let me put it this way. More than one figure on one graph area or one on the screen. For instance, if you may have 4 graphs and you want to position all the 4 on the screen, how do you do that? You want to display all the 4 graphs at the same time, each having its own graph properties, axis, and the rest. You use subplots to do that. So when you get to the hands-on, we'll look at all these commands. There are other controlling commands, that is for the axis. So you want to make the axis equal, you want to make the axis square, that is both sides, the x-axis side should be the same as the y-axis side so that the graph will look square. And then you want to make it tight, that is set the axis to the limit of the data, and many others that you can do. Okay. And then we have choosing symbols and colors. If you are drawing more than one graph on the same graph area, then of course you have to distinguish between the 2 graphs by using, let's say, different colors and patterns. But this is how we do it. We have, when you plot x against cos x, and you want to indicate that the color of the plot should be red, then the next space in the argument, that is the 3rd argument, is meant for the symbols and colors. And the first character is the character for color, and then the second character is the character for the pattern. So for instance, if you want your graph to be red, to have a red plot, and the plot should, instead of being a smooth line, should be plus, 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 plus. You should use the symbol plus, plus, plus to draw. Then you make it R plus. Remember to put it in quotes, single quotes. So that will make it a red cross graph. And then you can, there are many styles you can use. If you type help plot in the Octave, it will give you all the styles and you can use them. You can say B times. B times will simply give you a blue line. B means blue. Blue line with times as the symbol of the plot. So to use times to plot, you can use GO. GO will simply use a green, but then with 0, O as plus. You can do a lot of things with it. This is an example. We have X is equal to line space. In the previous lecture, I talked about line space. I said that line space can also be used in place of a vector, specifying a vector using the colon. So we want to get a range of values from 0 up to 100 using this interval. That is, sorry, it's going to give us 100 points. Go from 0 to going give 100 points with the 100 points will be between 0 and 1. 0 and 1. And the incremental value will be 2 pi. 2 pi. So we are picking that. I'll type it, then we'll look at that. We use that as our x values, and then we pass it to the cos to plot a cos graph, and then we make it red and plus, and then we have another one the same using the same vector sine of that, and this time we are making it blue x. So this is a typical example of plotting two graphs on the same graph area using the red plus and then the blue cross, blue times symbol. This is how it will look like. So you can see it. This is the red plus plus plus. You can see the plus, and then this is the times. You can see also all on the same sheet. So then you can also adjust the axis by either using the type or using equal, or specifying it in this form. You can also add the legend to it. So you want to indicate that the first one is for cos and the second one is for sine. You want to add some title to it and say it's trigonometric function. And then you want to label the x-axis as x and the y-axis as y. So these are all things. When you do, this is what you get. So you can see our y here, our x supposed to be here, but then it was chopped off. And then the title is also here, it's also chopped off. And then this is the legend, indicating that the red cross is for x, equals x, and then the blue times is for sine. So that is what we have. That you can use this CLF to clear the figure and controlling colors and markers. We have also talked about that. You can also look at the size, marker size. So the size of the plot, what you are using to plot, you can increase it or you can reduce it in that order. And then you can also type a text on the graph. So for instance, you can say 1 minus 0.5, and then this is a text. So the text is cos phi. One interesting thing about this one is that it accepts the LaTeX language. So if you want to type phi, the symbol phi, you can't get it on keyboard. So you can use the LaTeX command /phi or phi, some may say, and then it will give you the phi symbol. So the LaTeX you learned, please take note of even noted there. Note that LaTeX, note the LaTeX syntax. So LaTeX is used or is accepted in the Octave. Even the LMS we are using, to be able to type the mathematical formulas for it to appear as mathematical formulas, we use LaTeX. So those lecturers who are not familiar with latex have to by force learn latex command. So the latex you have learned, please don't take it as though you have just learned something for marks. No, it's for life. As a mathematician, you meet it in a lot of places. That's by the way. Let's continue. So this is all we get. So you can see that the XSX is reduced because here a marker made it marker 2, so it has reduced. But then this one is the default one, so you can see that this one is big. And this is the text on it. Okay. And the color too, you can see that this color looks pinkish, or it's a pink color. Colors are numbers. I didn't talk about that. You can mix the colors. We have what we call the RGB color scheme. The RGB, that's the red, the green, and the blue. So the first one is red, second one is green, and the third is blue. And they range from 0 to 1, so you can mix it. Here, the red is full, then a little green is poured in, and then much more blue is poured in to get this color that you see, the pink color. So that is another way of specifying the color. You can just say red R, or you can say color, and then you mix the color. So take note of that. These are other properties you have to know. That is, if you want to export the figure, these are the file formats that you can export to. You can make it JPEG, you can export as PNG, you can export as ESP, EPS, and the like. Okay, these are things that you can look at a later time. You can also plot using contour plots, scatter plots, a lot of plots, area plots, field plots, log, term, test, a lot. Bar, histogram, bar chart, pie chart, you can do all that. Then you can also plot 3D, you can use mesh, you can use surface graph to also plot. They are powerful, very, very powerful. So I will switch to our Octave environment, and then we will practice a few of what we have here so that you can also play with it. So let me switch to the Octave environment. So I'm now in Octave. You are familiar with this environment. First of all, let me use C. If I type CLC here, look at the prompt, command prompt. CLC, what do you think will happen? Yesterday, that's in our previous lecture, I talked about it. I said, this is clear screen. And if you want to clear history, you just make a history space dash C to clear the history. So I've cleared everything. We can look at it. You can type help and then plot and hit the enter key for see. It will give you a host of information about plots. So there's the syntax. You can plot Y, you can plot X, Y, you can plot. When it comes to plotting, when it comes to the line style, you can use a dash, dash, dash. You can use colon, you can use dash. When it comes to markers, you can use, these are all markers, crosshair, circle, star, a lot of them. All these things can be used. And then the colors. If you want black, say K, R, red, green, blue. Please take note of this particular thing. I can quiz you on it. Take notes. Take notes. Okay. Where to revise is enough. Please take notes. So there's many other things you can get in the document. Let me clear it and let's go with what we have to do. So we talked about plotting a graph. Let's try and also plot this. Yeah, we can the cosine graph. We can plot them and see how it goes. So first of all, we need to create the x values. We are saying between 0, 0 and then 100, 2 pi. We can decide to make it this way: 9 space, then 0, comma 2 times 2 pi, comma 100. So close. This is the same as just typing 0 colon. This time you not use comma, you use 0 colon 2 pi. So 2 pi is 2 pi. 2 times that colon, then 100. It will do the same. Now, if I want to suppress it, please, yeah, it doesn't respond to the mouse. When you click, it doesn't, so use the arrow key. If I want to suppress it, I'll just do this, semicolon. It means when I hit the enter key, I will have the values assigned to X, but it will not be displayed. So it's there. There's no display. If I want to display it, I can recall it and then remove this and hit this. So you can see my values. Okay. So okay. So I'm having 100 values starting from 0, and the incremental value is 2 pi. So from 0, the next one is 2 pi. That is 2 pi plus 0 is this, plus another 2 pi, plus another 2 pi, plus another 100 of them. So that will give us the last. So this is what the function we'll use to plot. So I'll come to the next line. I say plot into brackets. My x is now ready. Cos x. And remember, it's a function, so you have to put it in an argument. And then I want the line to be red, but this time not plus. Let's use O. And then we are plotting a very simple one. Okay. So this is what we are plotting. Okay. Then we hit the enter key. We can put semicolon to suppress it, or leave it as it is. So hit, and then the graph will be plotted in another window, not in the same. It's plotting. You have to give it some few minutes, few seconds, also depending on your processor speed. So don't force it. It will plot, especially when it is the first time you are plotting. When you open it, sometimes it takes some time to plot. So let's wait and see. Okay. So it has finished plotting. I have it here. Then I need to share, since it's a window, I need to share it. So this is okay, it's already. So this is it. Remember, I use O. Okay, I was trying to zoom. And then, all right. So as you can see, this is course. And of course, course starts from 1, and then it goes in that order. Right. These values, you can increase them either by command or by preference. You can work on it. So don't see the values are too tiny. You can always go to preferences and then work on it. We will do that later. Right. Time will not permit us. I need to go into that right now. So this is how it plots. Okay. Let me close it. And that is the, let me plot it again. This is the figure. Yeah. So this is figure 1. I told you by default it will give you figure 1. That is figure 1. If I keep this and I plot another one, that will be figure 2. And I plot figure 3, plot figure 4, in that order. So this plots nicely. To still, you can add grid lines. These are things that buttons you can click to do the same thing as the commands. You can click to remove the axis. You can click for the axis to come. You can click to insert the text. So then I can type. You can adjust the size of the text and all that. So I can say course 5. So it's there. I should have changed the font size and increase it so that when it comes to see it, course 5. I can even change the color of it. There are many things. These are up to you. See, I type 5, but now the 5 symbol is showing. You can see it. You can see it. So these are many things you can do when you are creating your graphs. Let's plot 2 graphs on one. So plot. Let me just recall. I told you you can use the up arrow to recall what you have already typed. They use the arrow left and right arrow keys to go and edit. So I can keep this and then type another one, sine. So x, comma, sine, bracket x. And what do I want to use to, I can use, let's say, green and put symbol star. Remember to put them in single quotes. If you don't do, it won't come. So I put them in single quotes and then I hit the enter key. Hope everything is right. Good. Hit the enter key. See, because I've already I've plotted one already. The second one came very fast. So you can see there's the plot. Let me be sure if you are seeing. Okay. You're seeing this. I'm sharing. Good. So this is the screen. You can now see. So we can decide to add the legend and all that. I can add the grid here, or I can type turn on grid, turn on the grid, and many other things I can do with my graph. So it's very simple to create a graph. So let's try a few things with what we have plotted and see. We want to add title, we want to add all those things to the graph. Let me go to the environment and then do that. So I'll minimize it and I'll say title into brackets. It's a string, so you have to put the quotes there. So it's a trigonometric function. Trigonometric function. And then the next one is the axis. So I can say X label, and then I give it to the X. And then Y label. I want to put Y there. Always remember to bring your quotes. And then what again? Legend. Legend. So the legend I have cost. Cost X as the first one, and then sign X as the second one. And I close for legend error expecting label to be. Oh, I didn't. You see, so these are some of the things. It's good to get error. I omitted the code here. So just as I've had error, remember if you do same, you will get an error. So take note. So you have this, and I have all my codes closed. And then you can go and see. Okay. All right. So we have all these things. Let's come to our graph. And you can see them. Just that their sizes are not huge. Let me share this. You can see them there. And then the sizes. Let me use the magnifier to magnify it. So, so you can see the y here. You can see the trigonometric function here. You can see our x also down here and all that. But I said that you can change the settings for these ones to come as bold as you want them. Okay, so we have our labels and the legend is here showing the cause and the sign. Let me use the magnifier. Okay, so you can see the legend here. You can see we have cos x and sin x. So the circle is for cos x, the star is for sin x. Okay, so that is that. Let's see. So that is our graph. It can be complex graph with it. And read much more about it if we do it this way and leave you and let you play with it and go through the notes, use the helper, go on the internet and learn more about how to use Octave and Matlab create graph. Time will not permit us to do everything. What I'll do is I'll expose you, give the basics, and then you can do the rest. Thank you very much. Our next lecture will be on programming, and that will be my last lecture with you, even though there are many other things we can talk about. But as we all know, we are not in normal time, so I will not be able to keep almost everything on you through video. So go through the notes, PowerPoint. When you go through it step by step, you'll be able to do everything. Make sure you are practicing them. It's very important. And when you have any question, you can post it on the platform. That's the Telegram platform where I am also on. And I'll, I'll respond to it. Thank you very much for paying attention to watch this video. I hope to see you in the next class or in the next lesson. Bye.